I'm Mr. Malden, and this is the Math Toolbox. Today we are going over rational numbers and absolute values. Specifically, we're just learning how to classify different rational numbers. And also, we need to understand the difference between absolute value and opposites. So let's just go ahead and get right into this. We've got this as our bell ringer. All right, or our introduction. Order the following integers in order from least to greatest. And we've got the following integers right down here. 3, -3, 10, -7, -8. One thing I see pretty common, by the way, with introductions like this, it's always a good idea to pause the video, then try it yourself, and then come back and see what the correct answer is. So you can go ahead and pause it now, but I'm going to keep on going. All right. With ordering rational numbers like this, or integers, sorry, a lot of times when students first do this, I see this as an answer. I see 1, -3, 3, 5, -7, -8, -10, and 10. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's 8 numbers. That's what I normally, not normally, that's this one kind of somewhat normal answer that I get. And essentially what the person did, whoever did this, and by the way, if you did this, you're normal. This is not correct. But if you've done this, it's pretty normal when you're starting to get introduced to positive and negative numbers. What they did was just order them by the actual number because, as you're growing up, you're just thinking about, as your parents taught you how to count 1, 2, 3, 4. You get used to the idea that 10 is greater than 1, You get used to that idea. So when we pull in negatives, a lot of times you'll just group those two numbers and you'll put the -1 on the left side indicating it's less than the positive one on the right side. But again, those are wrong, and the reason why it's wrong is -10 is significantly less than +1. So what I like to do whenever I'm teaching students to begin with how to order positive and negative numbers, I'll start by teaching them to place them on the number line. All right, so number line here, we have 0 in the middle. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's -10. I'm going to go ahead and plug it on there. That's where the -10 goes. I probably should have started with the one farthest to the left. There's 1. It's right there at 1. All right. Then we've got -3 right here, +3 right there, +5 right there. So all I'm doing is I'm plotting the numbers on the number line itself. -7, there's -3, 4, 5, 6, 7. All right, -8 is right next to it. Whenever you're doing negatives, it's going to, sorry, back up for a second. Positive numbers on the number line are to the right, starting at 0 and going to the right. Negative numbers are starting at 0 and going to the left and going down from there. So you'll have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and those would be negative right there. All right, we still got to we did -8, we did -10, and then we have 5, 6, 7, 8, 9, 10. There's +10 right there. All right, the question itself said order the integers in order from least to greatest. So if it's least to greatest, then we would go left to right. If it's greatest to least, we'd go right to left. But least to greatest, we have -10, then we have -8, and all I'm doing after I plotted the numbers right here is I'm just reading them from left to right. Then -7, then -3, then 1, 3, 5, and 10. And now I've ordered them from least to greatest. So if you paused earlier and you tried that yourself, you can check your answer against the correct answer right here. All right, there we go. All right. That was the introduction. We need to go ahead and get into the lesson today, which was to be able to classify different irrational numbers, all right? So let's just take this step by step. Rational numbers. Rational number is going to be just about every number that you'll ever use in life on a normal basis. all the rational numbers that you see, all the numbers that you see here on the screen right there, those are all rational numbers. The definition of a rational number is any number that can be represented as a fraction. That's the technical definition. But essentially, it's any numbers with decimals, fractions, whole numbers, complete numbers, negative numbers, positive numbers. Just about every number under the sun is a rational number. And if you're in 7th grade, 6th grade, every number that you've ever used in your mathematical career has been a rational number, all right? So these are all rational numbers. But some of these numbers are not only rational numbers, but they also get another title as well. They get titled, here I'm going through all my animations, but some of those numbers can also be classified as integers, all right? So again, those are all rational numbers, but some of them get a more specific label. All right, integers. Integers, what are those? They are positive and negative complete numbers. That's how I like to describe them. Technically speaking, the definition is an integer is 0, and including 0, it's all positive whole numbers. So numbers like 1, 2, 3, 37, 48, 1 million, all of those numbers. Any number, any positive number without a decimal, and then all those positive numbers opposites, all right? So like the opposite of 3 is negative 3. So both of those would be integers. 3 and negative 3 are both integers, all right? Again, that's the more complicated technical way to define it. The way that I describe it is any positive or negative complete number that is an integer. And so you can see here on the screen, you've got negative 100. That's an integer. 0 is 16, 3, negative 9. All right, and then I've got these fractions over here. But if you'll notice, these fractions simplify to complete numbers, to whole numbers, or in a positive sense. In the negative sense over here, a negative complete number. So a fraction, again, a fraction, you just want to see it as division. So you've got 8 divided by 4. Well, 8 divided by 4 is 2. We remember that's negative. So that negative 8 over 4 is really negative 2. And that's why it's an integer. It doesn't simplify to a number with decimals, right? So that's why it's an integer. And this one right here, 6 divided by 3 is just positive 2, all right? So those are both still integers because those fractions simplify to complete numbers, numbers without decimals. All right, so you have rational numbers. Just about every number that you'll ever use, all right, is a rational number. Integers are any rational numbers that don't have decimals, essentially. All right, don't simplify to numbers with decimals. All right, and then finally, whole numbers. Whole numbers are all the integers that aren't negative. Okay, so you've got 0, 16, 2, and 3. Those are all whole numbers because they don't have decimals, all right, so they're integers, and then they're not negative, they're positive, all right? So again, just to wrap it up, rational numbers, any number that can be represented as a fraction, just about every number you'll ever use. Some of those get a specific name called an integers, the ones without decimals, and then some integers, the ones that are positive, have another name called whole numbers. And then there's one other category, which are all the whole numbers except for 0. We call them natural numbers. Some people also call them counting numbers, all right? Counting numbers or natural numbers start at 1 and they go to infinity positive. Again, no decimals. So that's how you classify numbers. Rational numbers have a bunch of subcategories that you see right here on the screen. Integers, whole numbers, and natural numbers, all right? But what if a number is not a rational number, all right? There's some other numbers that we don't use very often that are not rational numbers. They're irrational numbers. And here's some examples of them. Probably the most famous example is the number pi, all right? Pi, we're going to use that later on in the year when we're talking about area and circumference of circles. It's the only irrational number, all right? Pi is an irrational number. It's the only irrational number that we use somewhat frequently in our world. Okay, so irrational numbers, what are they? They're any number that cannot be represented as a fraction, all right? So pi is 3.1415 ... Okay, these dots down here, if you ever see these dots, all right, those dots after the number, that indicates that this number is going to keep on going forever, all right, to infinity, all right, and these numbers don't repeat, all right. That's different than a number like this, for instance, all right. This number right here, all right, both of these, the dots and this line over a number, all right, indicate that there's going to be an infinite string of numbers after this, or it's going to keep on going forever. The dot means these numbers are going to change, all right. The line over the top just means the number is not going to change, that the number is just going to repeat over and over and over, all right. There's a difference between these, all right. This one is called an irrational number, all right. You can see right there on your screen, all right, the irrational numbers. And then this one, this one right here is a rational number because it repeats. So let's go back to kind of talking about irrational and rational, all right, and why we call one irrational and one rational. If you think about the word rational, rational is something that can be understood. All right, something that you can wrap your mind around, all right? So when you have a number like this, all right, even though it repeats forever, I could still wrap my mind around it because I know what number comes next. If I were to write it, the next number would be 3. And the next number after that would be 3. I know what comes next because this tells me that the 3 is repeating. The reason why this is irrational, right, is because we can't completely understand this number, all right? Even the smartest person in this world, even the people that have, 1,000 digits of pi memorized after the decimal, even those individuals don't completely understand pi because we don't know what the last number is. What's the last number? We don't know, all right? And plus, we don't know what the last place value is, all right? A rational number is a number that you can represent as a fraction, but an irrational number is a number that you can't represent as a fraction, all right? So let's just take a rational number, for instance, 0.35, and let's represent it as a fraction, all right? If you're taking a decimal and representing it as a fraction, you're going to take the numbers that you see, put it in the numerator, all right? And then you're going to take the place value of the last number, all right, and you're going to represent that as the denominator. So if the place value of the last number is hundredths, then 100 goes as your denominator, just like that. So you can represent 0.35 as a fraction, and therefore it's rational, all right? All right, but let's take this one, for instance, all right? Just using that thinking that we just used, all right? If you're turning a decimal into a fraction, you're going to take the numbers that you see, all right, and represent them as a numerator. But if these numbers keep on going forever, we don't know what numbers are going to end up being put up on top of here. And to explain it even, or to justify it even more simply, we don't know what the last place value is. All right, the last place value, it goes on forever, so there's not going to be a denominator because we don't know what it is. All right, and because we don't know what the last place value is, we can't represent this as a fraction, and therefore it's irrational. All right, it's irrational. All right, so you've got a lot of different examples, or a few different examples here on the screen of irrational numbers. Pi is an irrational number, and then the square roots of a lot of numbers are irrational, right? And we'll talk about square roots later on, but you can just remember that these square roots of most numbers are irrational. But again, just about every number that you're ever going to use is going to be a rational number because it's going to be a number that you can represent as a fraction. That's a rational number. All right, let's move on. With ordering numbers, all right, because that was one of our objectives when I was teaching these lessons. These lessons kind of went over a few day period. Whenever you're ordering numbers, whenever I'm ordering numbers, I like to use a number line, especially when I'm starting out trying to understand the numbers. I like to use the number line. It's just a great tool. All right. So again, we talked about this already, how a number line could be useful in like ordering integers. All right. Because you can simply just place them on the number line, and then you can read them either left to right if it's least to greatest, or right to left if it's greatest to least. All right. So let's just take this as an instance, for instance. How are we going to then, if number line, so let's back up for a second. We have a number line here that only has integers on the number line, all right? So I said a number line's a really great tool for ordering numbers, all right? With an integers, which are positive and negative complete numbers, it's pretty straightforward how you would do that, because you're just going to place the dot straight on the line right at the number. So if we're plotting -3, we're going to put a dot at -3, and we've graphed that, right? So again, number line, it's a great tool. But what about if you have rational numbers, all right, which are numbers with decimals? How are we going to put those on the number line? Because, if I were to put these numbers on the number line, I've got a number line here, 0, 1, 2, 3, all right? Well, I've got these numbers over here that are decimals, which are going to be like in between somewhere, right here in between 0 and 1, or in between 0 and -1, all right? So it's really hard to see that, and it's really hard to plot that. So how are we going to use a number line for that, all right? I create a special number line, all right, for organizing rational numbers, because rational numbers are numbers with decimals. A lot of times they give us numbers that are in between two integers. Like these numbers right here are in between either 0 and 1 or 0 and -1. So like 0.07, that's going to be a number that's in between 0 and 1. It's going to fall, just a little bit more than 0.5, right about over here, all right? So I like to, all right, whenever I'm organizing or ordering rational numbers, which are numbers that have decimals, I like to make a number line that is very useful for to edit my number line to become very useful for ordering these numbers. So the way that I'll do it is I'll start by zooming out the number line, so not making such a tight number line like this, for instance. I wouldn't make such a tight number line with 0, 1, 2, 3, where you can't really have much space to be able to put the decimals inside there. Instead, I'm going to make a number line where I'm kind of zooming in, if you will. All right, I place 0 in the middle, place 1, and then -1 over on the side, just like that, and where I have a lot of space to be able to put my decimals on the inside here. So the way that I do it is I split the middle, all right, and that middle is going to be 0.5 and -0.5, all right, split the middle, and then in each section, I'm going to add 4 lines. So I'm going to go 1, 2, 3, 4, kind of equal distance apart. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, just like that. All right. So again, just to be ultra clear, let me show you again how I do that. All right, I split the middle. I got 0.5 on the positive side and -0.5 on the negative side. And then in each space, I'm going to write 4 different lines. 1, 2, 3, 4 in each space. 1, 2, 3, 4. 1, 2, 3, 4 in each space, just like that, equal distance apart. And when I do that, I've effectively made a number line for tenths, all right? Because this is 0, that's 0.1, 0.2, 0.3, 0.4. We have 0.5 here in the middle, then you have 0.6, 0.7, 0.8, 0.9, and then 1 whole right there, just like that. So it's a really easy number line to create if you kind of do it the same way every time. Again, 0, 1, split the middle, that's 0.5, add 4 lines in each space like that, and now just really quickly, you have a number line for tenths, okay? All right, well, when you do that, then it's really easy then to go back and plot your numbers there on the number line. We have 0.7, -0.5, 0.2, and -0.3, all right? And I could call that 7 tenths, -5 tenths, 2 tenths, and -3 tenths, all right? So those are our numbers right there. We need to plot them. I'm going to go to 0.7. There's my dot. I'm going to label it right over the top. Sorry, not -0.7. That's just regular 0.7. All right, then I'm going to got -0.5, then I have 0.2, just like this, and then I have -0.1, 0.2, 0.3, just like that. And then I can read them. The question said, order them from least to greatest. So once I've put them on my number line, I'm going to read them from right to left. So the least would be negative 0.5, and the next least would be negative 0.3, then you have 0.2, and then 0.7, just like that. All right, so that would be my answer to the question. I'll just box it in. And I've got a really messy board, I know, but hopefully you can kind of understand how I did that. So again, classifying rational numbers is one thing, ordering them is another thing, and whenever you're ordering rational numbers, I like to use a number line. All right, I'll move on. You can see how I just did that with the animations that I plotted the numbers there on the number line so that you could see them. All right, so I want you to try this one, all right? If you'd like to, you can go ahead and pause the video, and I want you to try to organize these numbers. Now remember, whenever you're ordering rational numbers like this, it's really, really, really important that you take these fractions, any fractions, and you convert them to decimals first, all right? And maybe you don't know how to do that. Let's just pretend like you don't know how to do that. So let's just take 2/5 for a second and make that into a decimal, all right? A common misconception is you take the two numbers and you put them behind the decimal. Don't ever do that. It will get you, it'll be a right answer maybe 1 out of 1,000,000 times, all right? The right way to do it is to recognize that this fraction is division, all right? The fraction bar is a division bar, all right? And what you're doing is you're dividing the top number by the bottom number. So I use an acronym to help me remember, right? The division is a division table, and I put the top number on the inside, the bottom number on the outside. So I call that TIBO. It stands for top, in, bottom, out, right? So if you're converting a fraction, all right, to decimals, you need to recognize that it's division. The top number goes inside the bracket, the bottom number goes on the outside. Then 5 goes into 2 0 times, all right? That should prompt us to take a decimal to the top and put a 0 after the decimal inside the bracket. Now then we have a number that 5 can go into. 5 goes into 20 4 times, all right? 4 times 5 is 20. 20 minus 20 is 0. So 2/5 is the same thing as 0.4 or 4/10, all right? So extremely important here to take your fractions, all right, and convert them to decimals before you try to put them on the number line. And I just did 2/5 right there, but this is a negative 2/5, so just remember that if this was a negative, then your decimal is also negative 0.4, just like that, which if you know how to make a number line for tenths, that should be really easy to go ahead and put on there. All right, that's the bell ringing. I have students coming here pretty soon, but let's go ahead and, yeah, I'm going to go ahead and end the video there, all right? I'm going to show you kind of how to do this one. If you've already done this one, show you what the right answers are, all right? So again, on the number line, we're going to organize it for tenths by splitting the middle, drawing 4 lines in each space, all right? Then we can go ahead and put our numbers on the number line, all right? We converted 2/5 to negative 0.4, and 3/5 would convert to 0.6, all right? And so we'd locate it on the number line and would label it as it was. All right. I hope you enjoyed this lesson. This was just about, we just ended up getting to rational numbers and ordering rational numbers. We'll get to the difference between opposites and absolute value on another day. All right, have a great day. Okay, bye-bye.